Hello friends, I welcome you all in this session. As you are aware, in previous session we were discussing about a technique which we generally use for analyzing categorical data or non-numeric data, and the technique was chi-square goodness of fit, wherein in previous class if you look at, we discussed whether the expected frequencies and observed frequencies are same or not. If they are same, then the chi-square value would be 0, otherwise it would be having some positive value. Let us look at some other applications of chi-square goodness of fit. It can be used as a testing for proportion, hypothesis testing of proportion of one sample, two sample or more than two samples. So, let us look at how this technique can be used instead of using z-test. So, let us take a manufacturer. In fact, before that let me give you a brief theory about this technique, wherein we are using goodness of fit test in place of z-test, right. So, when sample size is large enough, we always say that the sample proportions are normally distributed, and the following formula which we have used for calculating value of z when we solved questions on hypothesis testing of proportions one sample, right. So, let us look at a question like this. Let us say the engineer at a shop floor thinks that the 8% of products contains at least one minor flaw, and this is the hypothesis which he wants to test at 0.10 significance level, right. So, null hypothesis is that the manufacturing defects are 8% or 0.08. Alternative hypothesis, it is not equal to 0.08. So, it is a case of two-tailed test, right. It would be a two-tailed test, right, is not it. So, what the manufacturer or the manager at the shop floor he does is, he selects 200 products and he found only 33 items have got minor flaws, right. So, the p value or p hat value is 0.165 and the value of z is 4.43. Now, since the significance level is 95%, now it is not 95, it is 90%. So, the value of z is 1.64 plus minus, right. So, if you want to reject the null hypothesis, then the z value should be more than 1.65 or less than minus 1.64, right. So, if you look at this, z calculated is this, it means you are rejecting null hypothesis. So, this minus 1.64, so plus 1.64, and this is your z value somewhere here, right, in rejection region. So, we will reject the null hypothesis and we will say that no, the 8% products do not have minor flaw, right. Now, this is what we have done earlier, but the same example can be solved using goodness of fit test. Okay. So, we will say that the this type of situation can be viewed as a special case of chi-square goodness of fit test, where the number of classification equals 2, right. So, binomial distribution situation is there, right. So, there are just two classifications which are success and failures, right. So, here you have got k is equal to 2 and the degrees of freedom would be k minus 1, right. So, this is 1 degree of freedom, right. And we know that the observed frequency is this. Out of 200, let us say 200 samples, 33 are defective, right. So, it means 167 are non-defective, is not it? These are defective, these are non-defective, right. So, these are observed frequencies. Now, just look at this, these are observed frequencies of defectives and non-defectives, right. How to get expected frequencies? Since we know the sample size is 200, our assumption about population parameter is 0.08, right. So, just multiply 200 and 0.08. So, it comes out to be 16. So, 16 are defectives, right, and when 16 are defective, how many are non-defective? 184. So, it is 200 minus 16 is 184. So, you have got now observed frequencies and expected frequencies. Now, you can apply chi-square test and you can check whether observed frequencies and expected frequencies match with each other or not, right. So, the chi-square value from table is 3.84 and from calculation the chi-square statistics is 19.63. So, we will reject the null hypothesis because this is your rejection region, right. The critical value is 3.84, right, somewhere here, and this is your somewhere here, right, 19.63, which is in reject. So, we will reject the null hypothesis, right. What was null hypothesis here? That observed frequencies and expected frequencies are same. So, we are rejecting it, right, and the same and the conclusion here is similar to what we concluded when we solved the question using hypothesis testing of proportion, right. So, let us look at this particular question using Minitab, right. We will solve this question using Minitab. So, first we will solve this question as one sample proportion test, right. So, 1P, one proportion test. So, we need to enter summarized data. So, number of events, so you have got 33 and trials were 200, right. So, we need to perform hypothesis. Hypothesized proportion was 0.08, right. Option, so it is 90% significance level, right. So, method is normal approximation. So, alternative hypothesis is, just keep in mind, it is not equal to type, right. So, it would be a two-tailed test, right. Okay, click OK. So, p value is this, right. P value is it is 0, right. So, let us compare it with alpha value. So, here alpha is 0.10, right, and p is 0. Is p less than alpha? Yes. So, we will reject null hypothesis, is not it? We will reject null hypothesis, that is what we have done it here, right. And you can look at other values as well. Okay, you have got this confidence interval, z value 4.43, this is what we calculated, right. Just look at this, 4.43, is not it. So, you can solve just now we have solved this question using Minitab as one sample proportion test, right. Now, let us solve the same question using chi-square goodness of fit test. So, let us look at this question first. These are the data points, right, and this is your software, right. So, let us go for data entry first. So, you have got defects and non-defects, right. So, these are the FO observed frequencies and FE expected frequencies. 33 and 167, right. So, the total has to be 200, right, expected 16 and 184, right. Let us find out what is the value of chi-square. So, tables chi-square goodness of fit. So, observed count, this is observed count, categorical data Okay. So, a proportion specified by historical counts, right. So, expected values have to come over here, right. So, okay. Okay. So, let us look at chi-square value. Yeah. So, first look at p value, it is 0.02, right. So, 0.02 which is p value less than alpha? No. So, we will not reject null hypothesis. Let us look at once again, first look at chi-square value, right, it is 4.73. Let us look at whether we are getting that answer or not. So, yeah. The chi-square calculated is 19.63, 33,167, we will go for data entry 33,167, 16,184. So, if you look at p value is 0.02. So, p value is 0.02 and alpha is 0.01. Is p less than alpha? No. So, we will not reject null hypothesis according to this. It means there is some problem in data entry, right. Anyway, you can, in fact, we have worked out couple of examples using chi-square goodness of fit test, so that you can perform, not a problem. Anyway, we will look at some more examples wherein we will get chi-square value, right. So, let us look at next question. So, what we have done so far is this, we have calculated or we have used chi-square goodness of fit test as a replacement of Z test, right. Now, the chi-square goodness of fit can also be used for comparing two proportions, right. So, you will have let us say pi 1 and pi 2, or let us say the number of absenteeism in a company amongst males and females are same, right. So, you have got let us say 15% male are absent and 17% females are absent. So, we can compare whether these two proportions are same or not. Okay. So, let us look at this question just for example, proportion of females who are left handed is equal to the proportion of males who are left handed, right. So, this is your null hypothesis and they are not same is alternative hypothesis. If H naught is true, then proportion of left handed females should be same as proportion of left handed males, right. So, how to proceed for comparing two proportions? First calculate chi-square statistics, right. So, it is same as what we have done so far. So, this is observed frequencies, Fe expected frequencies, chi-square state for 2 by 2 case has 1 degree of freedom. So, how to find out this 1 degree of freedom? It would be like R minus 1 into C minus 1. So, R is number of rows, C is number of columns. So, if there are 2 rows and 2 columns, so it would be 2 minus 1 and 2 minus 1. So, it would be just 1, right. And you should keep in mind that the value in each of the cells of the contingency table should be at least 5, right. So, the decision rule remains same. If the chi-square calculated is more than the critical value, we will reject null hypothesis, otherwise we will not reject it. So, let us look at this question. the chi-square test statistics. So, let us say you have collected data from 300 people, out of them 120 were females and 180 were males, right. So, 120 females, 180 males. Out of 120 females, you have observed that 12 were left-handers and 108 were right. Similarly, out of 180 males, 24 left-handers and 156 right-handers, right. So, you have got these observed frequencies. Now, you need to calculate chi-square statistics. So, for that, first of all you need to calculate expected frequencies, is not it. So, expected frequency can be calculated by this formula, it is row total into column total divided by total number of people whom you have observed, right, n. So, here if you look at, there are two rows, first row, second row and two columns. This is first column and this is second column, right. So, row total is 120, column total 36 divided by Fe, which is 300. You will get expected frequency is 14.4, right. Similarly, let us say if you want to calculate expected frequency for this particular cell, right, cell number 22, right, second row, second column. So, it would be 180 into 264 divided by 300. Okay. So, expected frequency would be 158.4. Since you have got FO and FEs, just calculate chi-square statistics, which is 0.75, and at appropriate degrees of freedom, let us look at this. At 1 degree of freedom, chi-square value is 3.814, right. Let us look at how did we get this 3.814, right. So, at 1 degree of freedom, right, it is 3.814, 841, sorry. Okay. So, this is the critical value 3.841 and the calculated value is 0.7, right. So, critical value is 3.841 and this is calculated value, which is in non-rejection region. So, we will not reject null hypothesis and we will say that the proportions of male and female using left hand are same, there is no significant difference, right. So, there is not sufficient evidence that the two proportions are different. Okay. So, let us look at how to solve this question using Minitab. So, we will have data like this. So, let us look at this question. So, you can you should delete all these output first. So, you have got gender, you have got female left-handers and female right-hander, male left and male right. So, observed 120, it is 12, 108, 24, 156, 14.4, 105.6, 12.6 and 158.4. So, let us look at chi-square goodness of it. So, Let us look at output. Just look at this value. First of all, p value, right? Compare p with alpha. So, alpha here was 0.05, right? So, alpha 0.05, p value is 0.86, right? Is p value less than alpha? No. So, we will not reject null hypothesis. We will not reject null hypothesis. That is the conclusion we have made earlier as well, right? Now, let us look at chi-square statistics, which we have calculated, and the value is 0.7575, right. In fact, when we did solve previous question, we were not getting chi-square because we made some error while entering data, right. But this is the way in which you should enter data. So, this is how you can calculate the two proportions, and you can find out whether there is a significant difference exists or not, right. Now, what if the proportions are if let us say if there are 3 groups and you want to compare proportions of those 3 groups. Let us say the percentage of MBA boys passing a course, MBA girls passing a course, and PhD scholars passing a course. If you want to compare these 3 proportions, so what you should do? Again, you can apply chi-square test of goodness, right. So, you will say that null hypothesis is this, all these proportions are same and they are not same is alternative hypothesis. This is same, chi-square statistics formula will remain same. So, observed frequency in a particular cell of 2 by C. So, we are saying that there are 2 rows and C number of columns, right. F is expected frequency. So, the chi-square statistics at appropriate degrees of freedom would be calculated by R minus 1 into C minus 1, right. Here R is number of rows and C is number of columns, right. So, first of all you should compute the overall proportions when you have got a question like this. So, this is very simple, it is p bar is equal to x1 x2 to xc and the total observations, and the decision rule remains same. If chi-square statistics calculated is more than critical value, we will reject the null hypothesis, otherwise we will not reject null hypothesis, right. So, let us look at a question like this. Let us say in a city or in an area there are 3 hotels, right. So, there are 3 hotels. The table shows response to a question whether they will select the hotel again. So, there are 3 hotels, Golden Palm, Palm Royal and Palm Princess. A question was asked to 700 people total, right. So, when a question was asked to 216 guests of the hotel, of this hotel, and 128 said they would come again in that hotel and 88 said no. Similarly, in Palm Princess Hotel 186 said they will come again and 66 said no, they will not come again. So, you need to calculate first, it is called the overall proportion, p bar is 0.773. It is very simple. So, you have got 128, 199, 186 divided by total number of samples selected from each of these hotels, right. So, 216, 232, 252, right, 700. In other words, total said yes divided by total number of guests, right. So, these many percentage of let us say 73.33 percentage of people said yes. In other words, 1 minus 0.733 said no, they will not come again, right. So, let us find out expected frequencies. These are observed frequencies, right. So, for expected frequencies you just multiply the sample size with proportion for yes, right. So, it is 0.773 into 216. So, this is expected frequency. Similarly, this is expected frequency, this is expected frequency. How to get this expected frequency? It is 1 minus 0.773 is 0.267, right, multiplied by 216. So, this is one way of calculating expected frequencies. The other method I have already taught you, it is row total into column total divided by n, right. So, you can do the same thing here as well, right. So, let us say if you want to calculate this expected frequency, right. So, row total 513, column total 216 divided by 700, you will get 158.3. If you want to get this expected value, just calculate it using row total, right, row total, column total 252 divided by 700, right. So, after calculating all FOs and FEs, you need to calculate chi-square statistics, and in this question the chi-square statistics is 40.23, and at alpha is equal to this at 2 degrees of freedom. Why 2 degrees of freedom? Number of row minus 1, right. So, row minus 1 into column minus 1. So, how many rows were there? 2, column were 3, right. So, this 1 into 2 which is equal to 2. So, that is why 2 degrees of freedom. So, this is how chi-square distribution would look like. This is rejection region. So, the calculated value is 40.23, which is in rejection region, critical value is 5.99. So, you will reject the null hypothesis, right. And what was null hypothesis? That all these proportions are same, right, is not it? This was our null hypothesis, that the proportion 1, 2, 3 are same, right. So, we are rejecting null hypothesis. It means the proportions are not same, they are different from each other. So, in today's class we have discussed about hypothesis testing of proportions of more than 2 samples. Though we did work out couple of examples on hypothesis testing of proportions using 2 samples and using Z test, but in today's class we have used chi-square goodness of fit test for comparing proportions of more than 2 groups, and this is nothing but the extension of what we have seen earlier. So, you can solve any question, or let us say even if there are let us say 4 groups. So, you can compare their proportions as well. So, chi-square goodness of fit is quite a robust method which can handle hypothesis testing of proportion of 1 sample, 2 sample, 3 and 4 and so on, right. So, that is the beauty of chi-square goodness of fit test. In next class we will discuss some more points related to chi-square goodness of fit. Thank you very much.